Hello, my name is Harshavardhan and this here is the 555 time machine. So it utilizes the 555 timer IC in astable mode, meaning the chip functions as an oscillator, and the mode is this mode is often used when you need a stable and continuous waveform. The timing components in this mode typically consist of two resistors, R1 and R2, and a capacitor. The values of R1, R2, and the capacitor, or C, determine the frequency and the duty cycle of the output waveform. The duty cycle is the ratio of time the output is high to the total period, and it can be adjusted based on the resistor values. And when power is applied, it begins oscillating, and the output switches. Switches between high and low states in a continuous manner. So here, this circuit is essentially the previous circuit broken down into its components, showing that the 555 chip is capable of doing what all these three chips can do separately. So this one has a fixed frequency duty cycle, meaning it will oscillate at the same rate, while the circuit containing the 555 chip has a potentiometer, so the frequency can be switched. So right now it's here. All right, so now let's break down how the complex circuit works to understand the true capability of the 555 timer IC. So the complex circuit uses two op amps, a NOR SR latch, and an inverter. Okay, so the first part uses the LM358 chip, and comparators contain an inverting and a non-inverting input. So the two resistors here act as voltage dividers, both connected to pin 2, which is the inverting input. The non-inverting input is the button connected to pin 3. When the inverting input is greater than the non-inverting input, the output of the comparator would be low, thus the LED is now off. So if I were to press this button, allowing current to flow to the non-inverting input, the LED will now be on, as the non-inverting input will be greater than half the supply voltage from the through the voltage divider. Now the next component is this part here. This is the SR latch, and the set reset latch, and it's created from the 4001 NOR gate. Each LED is controlled by its own button, and no matter how many times I press its button, so for this LED it will be this button, it will stay on. However, when I press the other button, so right here, the reset button, the other LED stays on, and it latches no matter how many times I press it. So when both the S and reset inputs are low, the SR latch will just retain its original state. So right now they're both low, so it just goes into what it was before. And an important consideration is that when both are high, it can lead to an undefined condition, and this situation should be avoided in practice because it can lead to unpredictable behavior. The input section of the circuit includes two resistors organized in a voltage division configuration and a capacitor linked to ground, and this setup establishes a reference voltage level within the circuit. The first output, named discharge, is only active when the circuit is powered, and it plays a role in managing the timing. The second output serves as both the trigger and threshold inputs for the 555 timer, and these trigger and threshold inputs lead to the subsequent stages of the circuit where two operational amplifiers named set and reset are positioned. These operational amplifiers operate by equalizing their input signals and producing an output of 1 when the non-inverting input surpasses the inverting input, yielding a positive signal. Conversely, they generate an output of 0 when the inverting input exceeds the non-inverting input, producing a negative signal. The remaining inputs for both operational amplifiers are connected to a voltage divider within the 555 timer chip, and which contributes to the overall functionality of the circuit. And the final component of the circuit is the SR latch, also known as the flip-flop. It employs two NOR gates with one input of each NOR gate connected to the output of the operational amplifier, and this arrangement establishes an oscillating feedback loop, which is essential for the circuit's operation and also for the generation of the desired oscillations. Also, the 4069 inverter is used, so the inverter part, and that's just used to like rectify or like strengthen the output. Here is a Falstad simulation that shows current flowing through the circuit. Thanks for watching.